Okay, so we are going to look at Unit 1, which is Fundamentals. Just kind of what's the idea of chemistry and laying some foundations that we're going to use the entire year. So the first thing that we want to look at is the scientific method. Please note that the picture there is showing you that the scientific method doesn't have a distinct start and end point, that you can go back and revise and revisit, so it's more of a cyclic type process. Now, when we make observations and when we're collecting data, we tend to do it in two ways. We collect qualitative data, which means that we're looking at the description, we're describing it, we're using words, and then the quantitative, which is numerical. So the way I remember the difference between those two words is quantitative has the letter N in it, which numbers also have that letter N in it. So it's a good reminder of which is which. Once you've made your observation, you have a problem that you're trying to look at, and so you come up with a hypothesis. After you have your hypothesis, you start experimenting. You have an independent and dependent variable. The independent variable is the one that you change as a scientist. So I change is the independent variable. The dependent variable is the one that changes based on what I'm changing. So it depends. A control is what you use for a comparison usually. You're not changing anything, it is what it is, and then we're comparing it after we make some changes. If you have, once you've collected your data, then you can come up with your conclusion. Your hypothesis is valid or it's not valid. If enough people reproduce that exact same conclusion, then the scientific community can call it a theory or a law. The difference between a theory and a law is that a theory could change if we found out new information, where a law won't ever change. The law is always going to be the same. So the law of gravity, we know it's there, we have the value for it, it's not going to change no matter how much more research we do on it, where a theory could change. So the theory of evolution, the theory of the Big Bang, those are things that we think it's pretty good that those things exist. However, there still might be information out there that we're unaware of right now, and so it could change. All right, let's delve into actual chemistry now. So chemistry is a study of matter and the changes that it undergoes. So way back before chemistry was even a word, there was alchemy. And alchemy was simply trying to transform one substance into another substance. Usually it was gold. That quickly turned into, wait a second, we can't take this rock and make it into gold. There's something else going on here. What's happening? So that's really where we get into some chemistry. And so there's three basic building blocks of chemistry. You have the atom, which is the smallest unit of matter that maintains those properties. If you have the same atom, you have a group of things that all have the same properties, they all have the same number of protons, then it's called an element. Now, elements are found on the periodic table. Only those things on the periodic table are elements. So if you are looking at a list of words and you can't find that word or you can't find that substance on the periodic table, it's not an element. It's probably a compound or a mixture. So elements, single atom, all the same atoms, they have the same properties, same number of protons. A compound is when we take two or more of those atoms and we chemically bond them together. So down here in the corner is an example of a compound. These atoms are bonded together. They're different colors representing the different elements. Red would be oxygen, black would be carbon, so on and so forth. Now, if I give you a formula or I tell you the name of something, how would you know if it's an element or a compound? Well, remember, an element is on the periodic table. A compound is not. So that's kind of the first clue right there. If I give you a formula like H2O, which is water, we know it's a compound because it has two capital letters, H for hydrogen, O for oxygen. So if there's more than two capital letters, it's a compound. If there's two names, for example, sodium chloride, then it's a compound. Sodium chloride, NaCl, that happens to be our formula for table salt. If you have sodium bicarbonate, that's NaHCO3, that's your baking soda. That's sodium and hydrogen and carbon and oxygen. So you have lots of elements there. They're bonded together so they get a name, and that name is not on the periodic table. Now water, H2O, we call it water. That's called the common name for that formula. Baking soda is what you call sodium bicarbonate. You don't go into the grocery store and ask for sodium bicarbonate. You go in there and you ask for baking soda. So there's some elements or some compounds that we have given common names to. All right, so then we also want to look at changing the properties making changes to those compounds, to those elements, and see what happens. There's two types of changes we can do. We can do a physical change and we can do a chemical change. Now, those are based on the physical properties and the chemical properties. So a physical property is when we are describing it. It wouldn't change the substance. We're just describing the substance. So saying water is clear the color of the water is a physical property of water. To say that water boils at 100 degrees Celsius, that's a physical property because it's describing those changes. Make sure that you know that a phase change, or phase is talking about phases of a substance, are physical. So pH and pH there. Those things we're not changing the water. So if the water ended up boiling, it's still water. It's just now a vapor, a gas, steam. A chemical property would change the substance. So saying that paper is flammable is a chemical property of paper, because if I was to actually burn the paper, it would turn into black ash. So physical changes, again, are changes in the appearance of the substance, not the substance itself. So all of our phase changes, all of our physical changes would be examples. If you cut a piece of paper, that's a physical change to that paper because it's still paper, it's just now in more than one piece. Tearing paper, diluting color. So if we look at our picture here, we have dark red, and then as we add water, it becomes clearer. That's dilution. We're just diluting that color. We're not changing the substance. A chemical change actually changes the substance. And there are 4 indicators. So if you have one of these 4 indicators, then you know it's chemical. If you don't have one of these 4 indicators, then you know it's physical. So for example, changing the color. Now here we said we weren't changing the color, and that's because these are all shades of red. You have to actually change the color. So going from purple to green, that's a color change. That would be a chemical change. Now the one that you are experienced with is rusting. You have your nice shiny bike and then you leave it out in the rain and it turns ugly, corroded, brown. That's a color change. That's rusting. That's a chemical change. If you were to form a gas, that is a chemical change. So if you think back to elementary school, when we take vinegar and baking soda and we mix it together and it bubbles and it forms this volcano, that's a chemical change because you're forming a gas. When you bake, you're forming a gas in the cake, and that's why the cake rises in the pan. Form a precipitate. Now that's precipitate, not precipitation. So we're not talking about rain here. Precipitate, I would circle that word in my notes and I would write new solid. A precipitate is when you form a new solid. So there was no solid to begin with, and then all of a sudden you have a solid. Now a lot of times you're going to see that by the liquid turning cloudy. So cloudy indicates we formed a solid. A really gross example of this is when milk sours. If you leave milk out and it goes bad, it starts clumping up, and those clumps are the precipitant that is being formed. So precipitate, precipitant, those are just 2 different ways of saying the word verbiage-wise. But you're forming that new solid. And then finally we have a change in energy. If we put two things together and it releases a bunch of energy, that's called exothermic, releasing energy. And that's like your campfires. If you light a piece of wood on fire, it starts burning and going through its chemical process, and then it's giving off heat and light. Endothermic is when the reaction is absorbing energy, so it actually would feel cold to us. And so if you've ever played sports and you get injured on the field and the medic runs out and they pull out the little bag from their, or they pull out a cold pack from their bag and they crunch it up and then they put it on your injury and it starts feeling cold, that's an endothermic reaction. Hand warmers. If you go to a game in the winter time and you put those you crush up the hand warmers and you put them in your gloves to keep your hands warm, that's an exothermic reaction because it's releasing the heat. Okay, so this is the end of our lesson. Make sure that you've taken your notes in your notebooks. Make sure you've made a list of questions. You can either give me those questions before class or you can ask them during class. I'll see you next week.